With that, I want to introduce Joe Lowcamp, and I think we'd all agree our business is a people-first business, so we got to be talking about what's going on with the safety of our people. So let me introduce Joe, please. He's a principal consultant at ESIS out of Atlanta, Georgia. ESIS Health, Environmental, and Safety. He has 20 years of experience in industrial hygiene, focused on occupational and health standards, gap analysis, and solution development. He has a BS as well as an MS in industrial hygiene from the University of Central Missouri. Multiple certifications, including he's a certified industrial hygienist as well as a certified safety professional. So please join me in welcoming Joe.
So I want to say thank you to Neil through Trinity Industries. We've worked with Trinity for, I have personally for at least the last 15 years about. So Trinity has come a long ways, and this relationship we have with them, and Trinity asked me to come and give this presentation. So I'm a certified industrial hygienist, certified safety professional. We do a lot of different occupational safety and health consulting activities, but with that said, we're going to focus specifically on confined spaces. I'm going to go really quick through these slides. We can talk afterwards if there's any questions, but please be aware that this is not going to cover everything that we encounter with confined spaces. So here's our legal thing that we have to go through. We're part of a bigger insurance company, Chubb Insurance, so we have all of our legal aspects we got to mention on there, but that's what it says. As Neil said, I'm an industrial hygienist with the company. I've been in the profession for over 20 years now and have seen all different types of industries and practices. I like to say I'm that How It's Made show. I get to live that life. I get to see different industries, different practices, and different things every day. So that's just a little bit about me. We're going to cover a lot of just basic overview of confined spaces, and what I want to focus on for you guys is to, as we're moving forward, as we talk about ISO standards, health and safety management systems are very similar to management systems in structure and format. So with that said, we can encompass and incorporate confined space entry as part of that, and any other health and safety related practices that we have. And we're just going to cover some basic terminology. We all have been around tank cars. You guys have all been around them. You know that it's a confined space. We know that we have practices and procedures we got to follow. So we got to make sure that we are aware and follow those so we don't endanger ourselves. Here's the classic definition. If it meets these three items, it's a confined space. I haven't yet seen a tank car, a rail car. I guess some of them aren't, but most of them, at some regards, would be considered a confined space because it meets these three definitions. So here is not a tank car, but very similar. When we go into these things, we got to take care and protect ourselves, protect our employees. How many in here are health and safety professionals? How many of you are responsible for health and safety of your employees? I think everybody should raise their hand that we're responsible for the health and safety of our employees, because we need to think that. We need to not allow people to get injured on the workplace, whether or not that's our profession or we're involved in that activities. That management commitment we heard earlier, this is very important as well in our regards. Here's another example. Just because we may not be creating a hazard or we have atmospheric hazards we're going to go through, we may have other avenues or other issues that create hazards. So these are just some examples. We may be introducing the hazards, and like in this case. So we got to be aware that we may not have a hazard as we're physically going to go into the space, but we may be creating them. And that most often occurs when we're doing maintenance and repair activities on tank cars or other railroad vehicles. So once we know we got a confined space, we got to say, is it a permit required confined space? To know if it's a permit required confined space, we got to think to ourselves, is there a hazard or are we creating a hazard? by the activities that we're going to be doing on this particular maintenance activity. So does it have a hazardous atmosphere or contain the potential for? Are we going to be coating the cars? Are we going to be entering into the cars to muck them out to get rid of whatever the residue that was left in there? What are we using to muck out the tanks? Are we going to steam the tank cars? Are we going to use the old diesel fuel trick to clean out the crude oil out of a tank car before we go into them? Diesel has been used for many years and still used today, but there's a lot of different alternatives that we could be using that instead of diesel fuel. So we got to consider, are we creating a hazardous atmosphere or do we have one? Most of us aren't going to have issues with engulfment or internal configuration. Those are more or less, when we deal with full tank cars or full vessels. And then the fourth one is other hazards. The one thing I like to point out when we deal with hazardous atmospheres is this is the definition of, and I'm not going to go through all of them, but you'll see that all of these do matter. Flammable atmosphere. If we're using diesel fuel or if the car contained diesel fuel, what type of atmospheric monitoring are we going to be doing? How are we going to know if we exceed these levels? We're going to talk briefly about some of that because I see an industry that a lot of the direct reading instrumentation that we're using is not adequate for all the particular chemicals that we may encounter. So these are just some of the definitions. 10% of the LEL, or lower flammable limit. Combustible dust shouldn't be an issue for you guys, except for in applications where you're abrasive blasting. There may be, you may be creating a explosive atmosphere just because of the blast media being recycled and recycled and recycled. So it's things you got to consider. And then anything that's above any occupational exposure limit, whether it's an OSHA requirement, Occupational Safety and Health Administration, other standards, whatever it might be. And the last one is ideal H atmospheres. Are we creating them? What are they? This is just a link through how we know, how we find out. Most safety data sheets will not show this, so we need to be aware that we may be creating a hazardous atmosphere by what we're doing. We're going into a tank car, we're coating it, we're painting it, we're cleaning it, we're creating a hazardous atmosphere. And there's a lot of requirements to consider if we create ideal H atmospheres. Once we have a confined space, we got to be aware that any physical body part, arms, legs, heads, anything that breaks the plane of the opening is considered entry. So if we're doing any work with any vessels or tank cars, we need to be aware that just by physically going into them, we've crossed the plane and therefore have entered into that space. And that starts triggering all the elements of the program requirements. Within the OSHA regulations, when we deal with confined spaces, there's a lot of ways we can avoid a lot of the requirements of OSHA. One of them is using alternate procedures, using forced air ventilation to control atmospheric hazards or the potential for. If we're not doing that, we need to. We can eliminate the hazards or control them in that regard. And why is it important? Because you don't have to comply with all permit required sections because we've effectively controlled or eliminated the hazards. This is just an example of forced air ventilation used in it's not a tank car, but a very similar application. The next way is if we don't have an atmospheric hazard, but there's other hazards present, how are we effectively eliminating those? Are we performing lockout, tagout? Are we ensuring that no material is in that tank? Are we eliminating those hazards prior to going into it? It's called reclassifying the confined permit required confined space because we're going into it. And we've eliminated those hazards. And again, it's important because you don't have to comply with all the requirements of the confined space entry standard. And one of those big things that's very hard to comply with for companies is the rescue provisions. And how are we entering into or how are we rescuing entrants that go into the spaces? Here's just an example of lockout, tagout. We've all probably been trained or been familiar with this particular type of activity. One thing I want to indicate, I've mentioned before, is we need to make sure that we're doing the right air monitoring for the tanks and the atmospheres that we're creating. There's many different styles and types of air monitoring equipment. There's things to monitor for. Do we have the correct meters? Do we know what we're doing? Diesel fuel is a particular interesting one because it's quite often used, and the standard combustible gas indicator, or LEL meter, will not work or respond correctly with diesel fuel. There are specific other instruments, photoionization detectors, and other things that are recommended by the equipment manufacturers if we're dealing with diesel fuel. So we need to be aware and ask the questions to the vendors, to your safety professional, to whoever it is, or do we have the right instrumentation for what we're dealing with? And the other thing we got to consider is, are we sampling in the right locations? This is a better scenario. This is from an OSHA Susan Harwood grant that just kind of goes through testing locations of a tank car. Are we going to test in all those locations? Probably not. But it goes to point out that you can't just test one location. That one location, is it representative of all areas of the tank we're going into? We got to think in the minds of where can we have trapped gases, trapped vapors, whatever it might be that create hazards to us. There's many different manufacturers out there. We don't recommend any one. I do have favorites. This particular manufacturer, Ray Systems, has technical notes that will help you guys or your facilities in developing and ensuring you got the right instrumentation for what you're dealing with. One of the things that's the new technology, I haven't seen it used in the rail industry yet, but with like some of the aerospace industries where they go into the fuel tanks of engines or the fuel tanks of the wings of like the C-5 Galaxies, they'll actually have heart rate monitors with chest straps that will monitor the heart rate, that will also they'll have the meter that they're wearing that will, all that stuff feeds real time into a computer that people will be able to send or dispatch an emergency response team if a man goes down, or a man or woman, or whoever is wearing that particular equipment. So there's a lot of new technology out there that we can, as we go forward, we can start thinking of that as we're updating our facilities. Forced air ventilation. When we talk about forced air ventilation, is bringing in fresh air into the tank when we're doing work. It can't create an additional hazard. I always, driving down the road, you'll see the AT&T or one of the road crews. They set up their guardrail around that manhole, and they got that little fan blowing into the space, and it's at a traffic light. And I think to myself, do they not realize that a car is idling right there, and you're just sucking in all that car exhaust right into the space, creating an additional hazard, right? So we've got to think about where we're placing that and what type of air we're bringing into the space. In the shipyards, if you're dealing with shipyards, they actually have requirements for certain the fresh air supply into those particular barges or vessels. Here's just some different types of examples of different units. One thing we got to be aware of is if it's a hazardous atmosphere and its potential for flame or flammable parts, we got to have intrinsically safe or explosion-proof equipment. So we don't want to create a hazard. We want to eliminate the hazard. There's specific requirements out there that we can talk about if you're interested. One of the things that we see quite often is health protection and ventilation for confined spaces when we're welding. Are we adequately protecting our people as we're going into the tank and doing repairs, doing welding activities? I wasn't here for the welding. I don't know what was covered in that, maybe quality, but one key aspect of confined space entry is appropriate requirements for welding and cutting in confined spaces. And when we look at this, we also got to know what we're welding on. We're not talking about all the different hazards, but we got to know if we're welding on stainless steel, carbon steel, mild steel, what type welding techniques we're doing. There's all these things matter when we're dealing with confined spaces. We always talk about hierarchy of controls when we deal with confined spaces. We want to eliminate the hazard first, substitute it if possible. When we're dealing with cleaning, mucking out tanks, that was mentioning diesel fuels commonly used, I'm sure there's vendors out here at this conference that will have products that are used as alternatives to diesel fuel. They actually have chemicals now that you can put into a confined space that will take that hazardous atmosphere or flammability part and eliminate that as the hazard. It'll convert it somehow chemically to a non-flammable atmosphere. Engineering controls, administrative controls, and then PPE is always the last resort. And that's because we're humans and we fail. We don't wear it right. We don't want to wear it. It's too hot. It's too cold when we start blowing in air. So all these things matter when we're trying to control atmospheres, and that's why PPE is always the last resort. Here's just some examples of ventilation that's poor. It's not the best way. You get a lot of problems with the way we're ventilating spaces. So there's certain ways of doing it and the proper ways of doing it. Here's another example of a guy welding in a tank. It's not a rail car, but very similar. More examples. Poor ventilation. And we think about ventilation, at least we're ventilating it, but yeah, a lot of that air that's being brought in is right in that opening and getting sucked right out. It's not ventilating the space, it's just being sucked out right at the opening, not where we're doing the activities. And then the last thing we're going to talk about is rescue. One of the things that I see as a big challenge in railcar maintenance activities is rescue provisions. If we're at a plant, it's usually a lot easier because we can train our staff, we can train our emergency response team, we can do certain things to either self-rescue ourselves, to non-entry rescue, or then in the plants we can do rescue. But when we're out in the middle of a field, if we have to go do something, for some reason you got to go into a rail car, there may be a lot of limitations to rescue provisions. This is self-rescue itself. You just recognize a hazard, your alarm goes off on your meter, and you get out. Non-entry rescue, there's many different styles of equipment that's available for non-entry rescue in confined spaces. This is just a tripod and winch system. You have davit systems. These are new tech, they're advancing all the time out there in industry. There's many different styles of this. Those are all considered non-entry rescue. We need to consider those in the rail maintenance industry because this eliminates the need for someone to go into the space and creating an additional hazard. You've all seen stories on the news of would-be rescuers that are fatally injured as well. Because even though we've been trained not to go in, it's my buddy, something happened, and I go in and try to rescue them. And then I become a victim as well. So non-entry is preferred. Entry rescue, there's a lot of things we need to be aware of for entry rescue. A lot of plants that we go to, or a lot of facilities or in different industries will decide they want to utilize the local fire department or the local emergency services, whoever that might be. Well, they may be out on a call somewhere and not available for the need of an emergency. They may be 10 miles away, and if they have to respond to your plant, it takes 10 minutes to get through your plant to get to where that location is. Is that 10, 15, 20 minutes? What's going to happen to the person if they're in that space? You know, we got to think that the local emergency services may not be capable of providing rescue for confined spaces. If you do rely on those, or your company does, you need to make prior arrangements and know that they can physically go in and enter those spaces. A lot of fire departments aren't trained in it, especially in the small communities when we have volunteer services versus a full-time rescue service. So here's some best practices. Consider, I saw earlier some people that here at the conference that will have robotic spraying applications, abrasive blasting applications, robotic. Cost money, but as we're looking forward to future, we can eliminate the entry into these if we're starting to consider robotic applications. Automated systems for cleaning rail cars, there's a lot of them out there. We don't have to go into the tank car necessarily. We can muck it out without going into it by using these automated systems, using a different chemical as an alternative, substituting abrasive blast media. One of the big things we see in today in the health and safety world, because OSHA passed the standard, is silica. If we're using a sand to do abrasive blasting, we got to get out of that. Sand is not to be used, shouldn't be used anymore. There's too many alternatives that can be used in place of that. And then, substitution. I put in there in this particular application, because we can work with the Railroad Administration or the people that do, the engineers that do the specs or the specifications. We got to consider fiberglass versus the refractory ceramic fiber blankets. We got to work with the regulators and all those that we can substitute a less hazardous material for insulation of rail cars. And here's just some standards, guidelines, best practices. American Petroleum Institute has several confined space entry documents. A lot of these deal with bigger tanks, but they can be applied in the rail car industry. NFPA standards. There's several of them out there dealing with confined space. Of course, all the OSHA requirements. If you ever have questions, make sure that you consult one of these books. Work with your insurance company, your safety professional, us, whoever it is. We're in this profession to protect the workers. And that's what we got to get to, is ensuring that we don't have confined spaces that injure people. A hazard, right? Rattlesnakes. Want to open it up to questions, concerns related to confined spaces, or if you have any other issues, we're here for any topic.
On the 5-gas meter,
Yeah.
what was the other gas that was checking versus the regular 4-gas meter?
So you have the LEL sensor for explosives or flammable atmospheres, O2, oxygen. I didn't mention it, but one thing we need to be aware of too in rail cars, if we're inerting atmospheres with nitrogen or carbon dioxide, your standard LEL meter won't work either. You got to have oxygen present. So we need to have certain infrared sensors on those. But then you got the usually H2S, hydrogen sulfide, and carbon monoxide. The other is a photoionization detector that measures organic vapors, and it gives you a readout. It won't measure everything, and it won't tell you what you have, but they're typical you can set up different alarm limits. It will measure a broad range of organic vapors. So benzenes, toluenes, ethyl benzenes, the old BTEX products from fuels, and diesel fuels is a good example, another one of that. Any other questions? Any other questions? I know it's lunchtime.
Yes, please. Good. Thanks, Joe.
Well, thank you.